Innovative geosynthetic materials in modern construction. Welcome to Blueprint to Reality, the channel where engineering concepts come alive. Here, we break down complex civil engineering topics into simple, practical ideas that anyone can understand. If you're a civil engineering student, professional, or simply curious about how modern infrastructure works, you're in the right place. Today's topic is innovative geosynthetic materials in modern construction. Introduction. Modern construction projects face major challenges, such as weak soil conditions, water seepage, erosion, and increasing load demands. Traditional methods like soil replacement and massive concrete structures are often expensive and time-consuming. To solve these problems efficiently, engineers rely on geosynthetic materials. These materials have revolutionized geotechnical engineering by improving soil performance, reducing construction costs, and increasing the lifespan of structures. In this video, we'll explore what geosynthetics are, the innovative types used today, and how they are transforming modern construction. What are geosynthetic materials? Geosynthetics are engineered synthetic materials, mainly made from polymers such as polyethylene, polypropylene, and polyester. They are used in contact with soil, rock, or other geotechnical materials to improve engineering performance. Geosynthetics perform 5 main functions: separation, reinforcement, filtration, drainage, containment. They are widely used in roads, railways, embankments, retaining walls, landfills, dams, and water control structures. Traditional versus innovative geosynthetics. Traditional geosynthetics include geotextiles, geogrids, and geomembranes. While these are still widely used, modern innovations have significantly improved their performance. Innovative geosynthetics offer higher tensile strength, better resistance to chemicals, and ultraviolet radiation, longer service life, reduced thickness, with higher efficiency, smart, and sustainable features. These advancements allow engineers to design safer and more economical structures. Innovative types of geosynthetic materials. High-performance geotextiles. Modern geotextiles are designed with improved strength and filtration properties. They prevent soil mixing while allowing water to pass through freely. They are commonly used in road subgrades, railway tracks, erosion control systems, and drainage layers. High-performance geotextiles increase pavement life and reduce maintenance costs. Advanced geogrids. Geogrids are grid-like structures used mainly for soil reinforcement. Innovative versions include multi-axial geogrids, polymer-coated geogrids, and glass fiber reinforced geogrids. These geogrids distribute loads more evenly, reduce deformation, and improve stability in retaining walls, slopes, and pavement systems. Smart geosynthetics. Smart geosynthetics are embedded with sensors or conductive fibers that allow engineers to monitor structural behavior in real time. They can measure strain, detect deformation, and monitor moisture levels. These materials are used in embankments, dams, and critical infrastructure where early warning of failure is essential. Geocomposites. Geocomposites combine 2 or more geosynthetic materials into a single product. For example, a geotextile combined with a geonet can provide both filtration and drainage. They are commonly used in landfill liners, tunnel drainage systems, retaining wall backfills, and canal linings, offering multiple functions in one layer. Environment-friendly geosynthetics. To support sustainable construction, modern geosynthetics are being developed using recycled polymers and biodegradable materials. Natural fiber geotextiles and recycled plastic geosynthetics reduce environmental impact while maintaining engineering performance, making them ideal for green infrastructure projects. Applications in modern construction. In road and highway construction, geosynthetics improve subgrade strength, reduce cracking, and extend pavement life. In slope stabilization, they prevent landslides and control soil erosion. In water management projects, geosynthetics are used for canal lining, dam seepage control, and drainage systems. In landfills and environmental protection works, they prevent groundwater contamination and ensure safe waste containment. Advantages of innovative geosynthetics. Innovative geosynthetic materials offer faster construction, reduce material usage, lower overall project costs, improved safety, longer service life, and better environmental performance. They allow engineers to achieve high structural efficiency with minimal environmental disturbance. Future of geosynthetic materials. The future of geosynthetics includes self-healing materials, nano-enhanced polymers, AI-based monitoring systems, and fully sustainable products. These developments will further transform how infrastructure is designed, built, and maintained. Conclusion: innovative geosynthetic materials have become an essential part of modern construction. They provide smart, efficient, and sustainable solutions to complex geotechnical challenges. As infrastructure demands continue to grow, geosynthetics will play a key role in shaping the future of civil engineering. Thank you for watching Blueprint to Reality. If this video helped you understand geosynthetic materials better, don't forget to like, share, and subscribe for more civil engineering concepts explained simply.